Thanks for everybody to show up to this webinar. Hopefully you're able to learn something. I tried to make this a little light, just kind of what we're doing at VRC and kind of what's new in the space. I'm guessing several of you are aware of who we are, but VRC is a company that was founded in 2013 with the idea of taking high pressure cold spray and making it hand operable. So we know the quality, the capability with high pressure cold spray. How do we put this in an operator's hand and allow them to fix parts on an aircraft, on a vehicle, or somewhere else in the field? Now, since then, we've also expanded significantly into the full manufacturing space of cold spray. So we do everything from stationary systems now to those highly portable systems and all kinds of other stuff, which I'll show you. We also like to work with a wide range of industries, academia, government partners. You see all of them listed there, and there's several more as well. And again, where we kind of see ourselves today is kind of wherever the customer is at, we try to meet them there. So a lot of people, that's just equipment, right? We need to supply them a system, they know what to do with it, and little training and they're off and running. But a lot of times there needs to be some substantial applications development or material research or process research or unique equipment developed for a particular application. And so we do a lot of that as well. We do play in the consumable space and with our nozzles, with powders, with various other stuff. So obviously supporting that equipment that we sell. We do full booth integration as well as some other integrated products, which I'll show you. But that could be robotics, whatever's needed for the job. And then one of the areas we're actually growing is our fee for service work. So this is actually, running parts for people, doing repairs, doing production work, things of that sort. And also operations support for people who own the hardware, who want to get a quick ROI. We actually go in and operate the systems for them. Today, our footprint is primarily across the US. We've got our headquarters in South Dakota. We have our FAA repair station. Mid-America Aerotech is up in North Dakota. Out in the east, northeast, we've got Webster, and then we also work out of a facility in Leominster with Salvis. And then we have 2 facilities that are full production facilities. These were really set up as pop-up cells, what the Navy calls pop-up cells. But it's just a full production setup with capability of handling very large parts and so forth. So these are just production facilities. So I'll go into that a little bit and kind of describe these facilities. So these, we have a full cold spray capability. So Raptor, cold spray system, dust collection, robotics, all the stuff you need to do cold spray. But we also have CNC mills and lathes and all kinds of stuff that you need to sort of prepare your parts. So just to give you a little feel for what these look like, this is a video taken of our facility in Chesapeake, Virginia. And you can see there's very large spaces for parts to come in, preparation of those parts, getting them ready for the job. We do have that CNC capability, both mills and lathes, and do the pre-machining as well as post-machining, as long as the parts fit in these machines, of course. We have our full cold spray booth. You can see here coating on a part. This is a Navy part. and, you know, just basic booth, dust collector, turntable, you know, your fixture table and so forth. We also do have nitrogen generation at the facility. It makes a much smoother transition than having to bring in bottles repeatedly. And then, of course, a full met lab for doing metallurgical sectioning and polishing and things like that. Do all your QC on site. And this also includes mechanical test capability. We can pull tensils and bond bars and all that. So that's about it. Just a standard production facility for cold spray. And what we can do there, here's an example. This is a shaft. Steel shaft needs to be repaired. You can see bad corrosion damage on it. So you do all the testing up front to qualify your process. Then we typically make a mock part or something that looks close to that part, especially if it's a unique geometry. This is a pretty simple geometry, but we still did a mock part because you can see there's some fairly deep areas, deep severe damage. So we wanted to make sure we could fill and then do a more uniform coating across the entire thing. So we filled the deep area, and then we did the fill on the full diameter. And so you can see by the time you're done, we have a you know, sprayed part in 2 or 3 areas on the shaft. On these, we actually did some rough machining of the coating to get it close to dimension, and then we give it back to the customer because the dimensions were extremely tight tolerance, and they had equipment that was better suited to grind it to the finished dimension. All right, so I'll give you an idea of the equipment. This hasn't changed really since last year, at least the top level pieces of equipment. So we have our Dragonfly. This is our highly portable system. This can be hand carried to wherever it needs to go. It's very lightweight, and it's also very simple to use. So the interface is like a 4-button interface. You can set it up on a robot if you want. You can set it up, you know, do hand spray if you want. And it comes preloaded with recipes as well. So if you work with us on a recipe development, we preload it in there so that, you know, it's pretty much just push button when you get it ready to go. The general purpose kind of system is really, it's our Raptor. This is it's used in stationary applications as well as portable use. It is on wheels. It can be towed around, lifted, hoisted, all that kind of stuff. But it's a little bigger machine than the Dragonfly, but substantially more capability as well, especially in the software space. A little more on the recipe development side, more data collection and so forth. So more of a production system. It's set up to be a production system for people. And then the last and the latest system is our Gen 4, the VRC Gen 4. This system has more substantial data acquisition and simplification of some of the data collection resources, as well as improved applicator heater, for instance, get you higher temperatures at the same high pressures that we have, the 1000 PSI, 69 bar. So very high pressure, high temperature capable. And it also comes standard with 2 powder feeders and things like nozzle cooling. So this is really set up to be a full production system, and it's also a stationary system. This is not meant for portable use. However, it does still have the ability to be set up for hand spray with all of our attachments, you know, for the Raptor and the Dragonfly and so forth. And then we also take and we integrate these systems into other, larger products. So this is a product I debuted maybe last year, the year before. It's called the Campsite. And this system is a fully contained cold spray capable product. So this has everything from your gas generation and your power generation right onto your cold spray system. So you can basically drop this anywhere you want in the world and you're ready to do cold spray when it arrives. The other system that's similar, right, portable, capable of taking the process to wherever you want to take it to, is called Abroga. So this is a trailer based system. Abroga 2 has similarly, it has all the capability that you need to do cold spray. So it's got the gas on board. It's got the robotics, and it actually has a deployable cart you could see there in blue to be moved to the process to wherever you need to do the work. So fully capable system. The Abroga 3 is a little lighter weight system. It's really just the cold spray itself and the robot. And the robot is attached to the trailer itself. So you stabilize the trailer, deploy the robot, and work on the vehicle. And this is just kind of a summary of some of this stuff, what's new. I think we've talked about the Gen 4. With the Raptor, one of the new things we're doing is we're actually, now that we have the Gen 4 with the applicator heater, we have a lot of customers asking us for that capability on a pre-existing Raptor or a Gen 3, for instance. So we actually have a product coming out where we can upgrade the Raptor to include the applicator heater, and then you have all the nozzle capability and everything else. And then we're actually in process on doing the same thing for the Gen 3. So this will allow that applicator heater to be incorporated into the Gen 3 as well. We're doing some demonstrations for the Campsite. We're actually going to have it in Webster during CSAT, so we'll be able to do off-site demonstrations there as well for anybody who's interested. The Abroga 2 is available to be used. We've done a couple demonstrations with that. I'll show one in a couple of slides here. And then we've got some improvements on the powder feeder side that are really moving along. The first is some improvements to the standard feeder, gives us a little smoother coatings and higher feed rates. Second one is a new feeder that does a much better job of feeding very fine and typically difficult to feed powders. And then another where we have a continuous feed mechanism as well for powder feeding. All right, so as we've kind of developed this applicator heater and rolled it out, we've also come up with other uses for it. And one that I'd like to show is this. It's a system that was built to be able to coat the interior of a pipe. And so I'll show the video here. It'll be easier to explain. So this whole thing is on rotating gas fittings and slip rings and so forth, so we could operate the cold spray system in a rotating fashion and coat the inside of a fairly large diameter pipe. This was a demonstration for a customer. This isn't a real part, but this is a similar part, a mock part of what they wanted in the field. So we are demonstrating this capability to coat that inside. And when you look at it, it's a very, very good quality coating, high adhesion strength, low porosity, and very good hardness for the material that we were applying. So we've also done some on-site demonstrations recently. One was this Reptex demonstration with the Navy that was out at Port Hueneme in California. And you could see here some of the things that we achieved there. First, we brought the campsite and we demonstrated that pier side to actually fix parts for the ship. Also taught some sailors how to hand cold spray in that campsite system, as well as doing the robotic cold spray. We also went on ship and did some demonstrations there. So this was an exercise where several demos were devised. Some of them included repair of the ship deck itself, like corrosion damage on the ship deck, or you could see some structure repair being done there. And we even had a situation where, we had to fill a hole in a door, right? So just where could we possibly use this technology and give it a shot and see how it works, and did very well. Also did a demo of the Abroga system. So this is the trailer-based system at Letterkenny Army Depot. Here we were demonstrating, again, the full capability of the system. So no assistance from the facility at all. This is just all operating off of our own generator, gases, and all that. And in this case, we did a little demonstration on a container, repairing a container. And then we did a demo on a hand spray demo on the back of a Humvee. So this is a trailer hitch for a Humvee. And we even had the operator from Letterkenny doing the hand spray. A few new exciting materials from my standpoint anyways. One is we're doing a lot with wear coatings. So we've designed and developed several different carbide-based materials. These are materials with either low or high carbide content, depending on what we're trying to achieve. So obviously low would give you a little more toughness, high would give you a little more wear resistance. So kind of playing that game. We've also done some work with Stellite 6, depositing that material, as well as other cobalt superalloys. So developing several different cobalt superalloys, one of which has a very high temperature and high hardness. So greater than 800 Vickers and very high temperature capable, oxidation resistant, and so forth. As well as some more moderate hardness sort of materials like the austenitic stainlesses with hard phases in them and so forth. We've also been working on some very low cost materials. This is another kind of exciting space because some of these repairs on very, very large parts can start to get costly when you have to work with a lot of raw material. And especially when you're dealing with air sprays, fairly low cost in every other way, but you end up spending a lot on powder. Well, we've been working on this low cost variant of a stainless steel powder that actually has pretty high deposition efficiency and is giving us decent properties. So again, general repair, it's not the most premium material, but if you're just trying to fill damage on large parts, good opportunity there. All right, a few areas of research. I'll get more into data and research in the CSAT talk in the next month, but I figured to give a snapshot here. We have done some system comparison trials. This was basically to evaluate the three systems that the Navy tends to use, right? So we've got a good amount of data on all three systems, but the Navy was looking for back-to-back comparison so they can have the data to verify that they can switch qualified spray process from one system to the next to the next. Now, really, these three systems have a lot in common. They use the same applicators, nozzles, powder feeders, gas heaters, hoses. So by and far, the bulk of the product is very, very similar. The big differences are in the way the gas trains are designed, the electrical design, as well as the software. And as one would imagine, we saw very comparable results in many of the different properties. There's still further testing, but we're seeing very good correlation between the three systems. Again, as would be expected by the broad range of similarity in those systems. Here's just a snapshot of the three systems with microstructures. So you see the Gen 3 to the left, Raptor in the middle, Dragonfly to the right. And then these are two different materials. One is a chrome carbide, nickel-based material, and then the other one is a copper nickel material. Did some surface preparation studies. I'll skip past the words here and get to the meat of it. So this was work we did with our ALO2 material, which is a 6061 variant material. And what you can see here is this is all very similar to ASTM C633. It's the D4541, which is that like POSI tester, right? It's a portable adhesion tester. And we get pretty good correlation between the two. And you can see here that all the way from the bottom here, which had no surface prep at all, and so this is a 6061 plate as rolled, as delivered. Did Scotch-Brite, grip blast, wire wheel, sandpaper, all the way up. And you could see that getting to that 10 KSI sort of strength, which is right where we want to be, you're doing a fairly substantial amount of surface prep with peening and wire brush and of course IPA rinses and even a little bit of preheating. So running the torch over the part a couple times before you start to spray. So this is very good information, and this is of course nitrogen sprayed 6061 based material. Now, when we did the same work with that same material with helium, of course, we get glue failures constantly. So, and the same thing with the CRC01, we did that with nitrogen and constant glue failures. So then we went to this ring shear test to evaluate even higher strengths for those materials to see, do we still see a difference between kind of different surface preps? And you can see here that going from no prep to Scotch-Brite to grip blast on the 6061 substrate, you could see the Scotch-Brite is the best. And then the worst is actually the grip blast, right? However, when you go to the CRC01, which was sprayed onto steel in this case, we see that the grip blast is actually the best. So here we're seeing what we believe is the effect of contamination with aluminum being able to grab onto that grit a little bit better. We think we're seeing bond line contamination issues with grit blasting on the 6061, whereas we don't see that on the steel. We also did some corrosion work, and this is primarily crevice corrosion. So you can see the little setup here. It's a potentiostatic sort of setup. And in comparison to two materials, and this was again Navy work, so these are two materials that the Navy likes to use, 304 stainless and a 7030 copper nickel. Now, keep in mind, more negative is going to give you more pitting, more damage of the part. So we want a more positive number, ideally. So what we can see is the 304 is that negative 220, copper nickels, that negative 71. So if we start to look at our coatings, we have an austenitic stainless steel, which is very similar to that 304. The chrome carbide nickel is actually a little worse in crevice corrosion because it does have that pure nickel in it. Nickel chrome's a little better. That's the CRC02 material. And then you can see the best materials are actually the copper nickel, similar to the wrought material, and then a Hastelloy-based material, which has much superior corrosion performance in comparison to the others. All right, so kind of what we're looking at over the next 6 months or so. We're finalizing the robotics for the AM systems, and we're building a prototype system, so we'll have that in place later this year, actually. We're doing a lot of work expanding those pop-up cells and bringing in commercial work into those pop-up cells, in addition to other DoD organizations too. So if there are needs for those, repairs, the job shop sort of work, definitely look us up on that. New materials, these new materials I showed are in the process of being finalized, but we do expect to have production versions of these ready soon, with all the data backing them to be able to put those on real parts. And then, of course, you're already seeing that we're doing a lot with that applicator heater, and we expect more expansion into kind of new areas with that, and expanding the capabilities of our portable repairs also with the different demos using the Abrogas and the campsite. And then the last thing, I think this is on everybody's mind, and we're definitely focused on it and have big plans for this over the next 12 months or so, is improving on non-helium based mechanical properties. I know a lot of people have done, many different things over the years, trying to heat treat in situ or ex situ or whatever, to improve performance and everything. We're doing some other stuff, trying to improve it in that as sprayed condition, and not really affecting the substrate with thermals and so forth. So we have a lot going on in that space, and we're seeing some good traction as well in improving those mechanical properties. So that's kind of where we're at. And with that, I'm happy to answer questions now, or feel free to contact me as well.
Awesome. Thank you, Aaron. So for the folks who are on the line here, you can throw questions actually through the Q&A box. So if you want to send those over as they kind of pop up in your head as we're closing out here, please do. And obviously you've got Aaron's contact info up at the top. Aaron, one thing that I think would be good to highlight, if you can, is I think you had mentioned maybe some campsite demos at CSAT. How can people get a hold of you guys to get those demos? What's the best way to do that?
So it'd probably be best just to reach out directly to me, and I'll coordinate it at my end. So.
Okay, perfect. Perfect. And then I think there's a follow-up question on kind of some of the Reptex activities and a lot of the kind of mobile demonstrations. Where do you guys see some of the kind of biggest activity or opportunity around those mobile repairs? It seems like there's a lot more of that popping up these days.
Yeah, I think people are just seeing that it's really possible. I think it kind of took putting systems like this and what other people have done, putting those systems together that can go into the field, that have all the capability, in place to do these repairs, and that's opened up people's eyes to the possibility. So, I mean, once you see something like the campsite or the Abroga or something like that go into go onto an air base or something like that and do a repair, and have everything you need, And that's kind of complicated. It's more complicated than it sounds. There's a lot of potential problems and a lot of learning that goes on over time. But yeah, once you see that that's possible, I think it opens up a lot of doors, and that's what we're seeing now. A lot of industry interest, especially big industry, heavy industry, people who don't want to move stuff. So the two areas I've always said for cold spray that are kind of the most important, or at least the lowest hanging fruit, are high cost items, which we've been doing for years with aerospace and so forth, or high cost to move items, things that you don't want to take out of service. So those are the people who are coming asking these questions.
Awesome. And I think there was a question a minute ago about whether or not this will be available for download and recording. So this video and the whole video series is actually available on the CSAT YouTube channel. So if you guys haven't seen that, definitely check it out. Aaron, another follow-up question, because I know there's going to be some different talks this year at CSAT around safety considerations and things like that. Would love to get your take on kind of that aspect of cold spray, the evaluations that you guys have done and others have done. Obviously, you're doing hand repairs, you're in all kinds of places. What's kind of the VRC take on safety and cold spray? So,
I mean, there's a couple different issues at play here, I think. One is, I guess, EH&S requirements, right? Like, what is some jurisdiction going to allow, and so forth. And then there's the operator safety piece. Like, what does it take to keep the operator safe? So the operator safety piece, that's something we've been working with for years. We have a very good handle on that. PPE is very important. Understanding the materials you're spraying and the allowable exposure limits and so forth, that's all very important. That's where we start every process. So when we're doing something, first things we do is have our experts look at the materials, see what the allowable limits are going to be, and then we do surveys on a fairly regular basis to understand what kind of exposure our operators have, right? So these are all really important things. Then having the proper PPE, so you saw people in garb with face shields and breathing apparatuses, all that kind of stuff, as well as gloves and so forth. So that's all for protection against contact with a hot surface, or also the gases and so forth. So that's all very important. On the more jurisdictional side, we've put systems in a lot of different places, and nothing is consistent. So it's really up to the local jurisdiction what they're going to require or not require. One thing we're trying out and seeing how this works is, like with the campsite, for instance. It's a fully self-contained unit. It's got everything in it. We've got it qualified, certified, and so forth. Now we take that to a new location, and how is that allowed to operate at that location? That's something we're learning as we go. But that's one area we're hoping, if we can create a product that is certified ahead of time, and then we bring it to a location with that certification in hand, maybe that will kind of smooth over some of the jurisdictional things. When you're stick building on site, it's always, a bigger deal than if you bring in the prefab,
Yeah, no, that makes total sense. I think that's something that, for everybody that is on the call, you need to kind of rally behind that to help boost cold spray adoption rates kind of across the board. And that's going to be a big part of the topic at CSAT, is how you make sure that we can streamline that process, because cold spray does have a pretty good reputation from that perspective. And so making sure that, we can kind of pave the way with our favorite AHJs is definitely going to be important. So it looks like we're out of questions here on the side, but I really appreciated the conversation here, Aaron. For folks who have any other last minute questions, you can feel free to drop them in here. Otherwise, obviously you have Aaron's contact info. There's also information in the chat down below about how to register for CSAT, LSAT, what the agenda is. You can see some of those topics about safety and powders and 3D printing and repairs and all kinds of fun application spaces in aerospace and nuclear energy. There's going to be a lot of really good conversation there. Aaron, do you have any kind of parting wisdom for everybody? Anything that you want to make sure everybody's taking home, especially into CSAT coming up?
Well, I would say just get out to CSAT and learn everything you can. That's the most important. Pick people's brain. There's been a lot of people that are going to be at CSAT that have been involved in this for years, and guys on the implementation side as well as on the development side, like we are. So I would go there with your minds open. If you're from an organization that wants to try to implement cold spray, I would definitely consider how you intend to qualify the process. That's usually the biggest hurdle, and figuring out how to do that. And we've worked with many different people, and everybody does it different. Every DoD organization does it different. Every commercial organization does it different. And we could certainly help you through all that, but having some idea of what the constraints are going to be on your side to getting something kind of qualified is a big deal. And usually we're looking for low-hanging fruit, right? That's, when I was on the other side of the fence looking to implement this technology, and I wasn't in the development side, I was trying to find those applications, those low-hanging fruit applications where I didn't have any other options. This was going to solve a problem for me, right? Those are usually the first things we go after, because there's a lot more latitude when you can't rely on welding, or you don't have a thermal spray process that's working for you already. You have nothing, and this is your only chance. So
I love it. So start easy and talk to people. Sounds like great advice. And we're a surprisingly friendly community, so you might as well reach out.
Yeah.
Perfect. Well, Aaron, I have to say thank you so much for the time this afternoon. And again, folks, if you have additional follow-up questions, feel free to reach out to Aaron. This video will be available on YouTube. Hopefully we see you all at CSAT, and looking forward to seeing what's next in cold spray. So thank you, Aaron, and the whole VRC team. Really appreciate your continued support of the cold spray action team. All right, y'all, have a wonderful afternoon.
All right, thank you. Have a good one.